All right, you've had a little background on what logarithms are and how they relate to exponential expressions. So let's go into some properties now of logarithms. We'll go through all of these: the product rule, quotient rule, power rule. And here are some of the basic properties. So again, our value for b has to be greater than 0, but our b cannot equal 1. And keep in mind that any power or any base raised to the 0 power is 1. Okay. And they're going through some of these, but I think the explanation of how we use them will be more important, but you might include these in your notes as well. So when you see something like this and you want to work it out, what might you notice here? Well, that the answer 8, write it this way, log base 2 we can also think of this as 8 is 2 to the 3rd power. So that the exponent of this is 3. Now, you notice something that's going on here where there is a 2 as the base, there is a 2 as an answer. Then in this situation, whatever is in this exponent position is the answer on this other side. Now you probably could have figured this one out too by just going to its exponential form. Base 2 to what exponent is going to give you 8? And if you recall, that was 3. But this is another little basic property of logarithms. When you have this arrangement, there's a 2 there and a 2 there, then whatever exponent is there, that's also on the other side. That's what it equals. All right, so let's take a look at the text here. So you're writing it in an exponential expression, and they're using rule number 4. So let's pause and go back to rule 4. And when the base and this is the same, then the answer is what's in the exponent position here, x equals x. One of the properties of logarithms. Now, in this case, the natural log, and the natural log, by the way, is of base e that we don't write. So, keeping in mind what we've just seen and rule 4, what will the answer be over here? Well, remember this arrangement, then it's just going to be a. Whatever that exponent would have been, that is the answer. Let's check it out. And natural logs have the base e, as we've mentioned, so that in this arrangement, where the base and this part is the same, the answer is just that exponent. A equals A. All right, let's look at this. Now, notice there is no base showing. So when there is no base showing for a log, it is base 10. This is called the common log. And we can take 1,000 and put it in this form. That would be 10 to the third power. So again, now the base is equal to this. So the answer here is 3. When these two items are the same, whatever is in the exponent position, that is your answer. This is rule number 4. And there is part of the answer, the common logarithm. When there is no base, it is 10. So the 10 and the 10, the 3 then will equal 3. Okay. Now, with your calculator, there is a log function button on your calculator, and it is the common log, base 10. So while you have your calculator out, try these, and you see they're going to be rounded off to 4 decimal places. Now, you have to be a little bit careful here, because if you just leave the value in your calculator, it's actually more than 4 places. But if you round it off, then that's where answers might be a little bit different. But again, by showing the work on your blue sheet, if it's close, I would give you the credit and not take off because it wasn't the super exact answer. And here they're mentioning what I've just said. Okay, now some other rules for logarithms. And let me give you a little bit of background on this. If we had x to the second times x to the third, what would we do to our exponents to get the answer? And the answer is you would add the exponents. Now remember, when we're dealing with logs, we are dealing with exponents. So in this rule, when they say log base b of xy, this is x times y, x times y. How are we going to illustrate that if we wanted to do what is called the expanded, or the sum of the logarithms of the factors? And here's the basic rule. You write log base b of x. Now, to indicate multiplication here, we're going to add these together. Log base b of y. And again, this comes from this. When we're dealing with exponents, we add them to indicate multiplication. So this is the condensed view, this is the expanded view, and this is what they're describing here. All right, let's go on and see an example. Now, we're going to use that rule we've just had. This is 3 times y. So, to expand this, the rule will be log base 2 of 3 plus log base 2 of y. Now, keep in mind a little later we're going to take this expanded view and convert it to the more compacted form. And there's the answer. Now, for something like this, again, following the protocol, it will be log base 5 of 3 plus log base 5 of 4. 3 times 4. We indicate, in a sense, these exponents by adding. So we're looking at the product rule for logarithms. Now, as background again, if we had x to the 5th over x to the 2nd, what would we do to show division here? Well, we said we would bring this item up, cross the division bar, and we would subtract. So, in regard to quotients, which is what these are, fractions, bringing the denominator up, we're going to subtract. So, let's clear this and look at the rule. So the log base b of y over x will become, as we use the expanded form, log base b of x. This comes up and we change it to subtraction log base b of y. So again, write this rule down and we'll see it in action here in the next few slides. So we want to expand this log base 10. We put the numerator first of 5. Now, since this is division, we're going to convert it to subtraction log base 10 of x. Now, for many of you, these are new things, so you want to be sure to take some good notes and understand what's going on. And there it is. Now, another way to write it, of course, since this is base 10, is not to write the base. You're converting it, in a sense, to the common log. But this would be the procedure if there were other bases. Let's say base 8 or something. Now, here we're dealing with base E, which is the natural log. So, we would write it log base E of x. Again, this is division, a quotient, so this would be minus log base E of y. Now, since this is base E, we could also convert this to its natural log form, natural log of x minus natural log of y. And here we see it. Now, we're going into what is called the power rule. And what we're building up to here is actually solving equations with logarithms, and we'll need these rules to operate how we solve these equations. Now, if we had x to the second raised to the third power here, this is the power rule. We don't add the exponents here. Here we multiply the exponents. This would be x to the sixth. So here it relates to this, but a little bit different. Here we have the log of base b, x raised to the r power. Now, converting this, the rule is when we have x here raised to a power, this power goes out in front of the log. So the exponent goes to the front, and this would be log base b of x. So when it's in this form, and notice the b and the x are different, so we don't use that rule 4 that we've used earlier. We want to convert this to its expanded form. The exponent goes out in front. All right, let's see some examples of this here. Now, for something like this, and again, things are coming to closure here on some of these things. This is going to be log base 10, but we don't have a way to deal with radical signs here. So I'm going to convert the square root of 2 to 2 to the 1/2 power. So we have to do that. Convert this radical, as you recall from an earlier lesson, is to the 1/2 power. So when we convert this, this is going to be log and we don't need to write the base 10 there, 2, but where are we going to put that exponent now? And the answer is out in front. We move the exponent to be in front of the word log. And that's how that's done. Now they've left the 10 there, and you could do that. And then if you were to simplify that, of course you would put in this value, log of base 2, and then take 1/2 of it, or divide by 0.5. Again, try that on your calculator. And when you do the multiplication here, it comes out to this. Now I also put this into my calculator without going through these steps, and I get the same answer. But again, if they're asking you to expand it, as is shown here, this is what they're looking for. So we're at 20 minutes, a little bit over, so this will be a two-parter as well. We'll stop here and pick up with example B, because I think we probably have another 20 minutes to go. Lots of important background stuff here.